Our presentation is by Sepehr, Charan, and Sepehr. So what is a muscle? In our case, we are talking about skeletal muscles, which are voluntary muscles that are connected to the skeleton and form the mechanical basis that moves our body. So muscles are divided up into subsections, the first being fascicles, then muscle fibers, followed by myofibrils, filaments, and then those filaments are made up of actin and myosin. The most commonly accepted theory for muscle contraction is the sliding filament theory.
The filament of a muscle contains actin and myosin. The sliding filament theory explains the mechanism of muscle contraction, based on muscle proteins that slide past each other to generate movement. In the myofibril of a muscle cell, there's a section called a sarcomere, which extends from one Z-line to the next Z-line. A sarcomere consists of many rows of actin and myosin. The actin is much thinner than the myosin. Around each actin is a tropomyosin strand. On top of some of the actin units is troponin. The troponin interacts with the calcium ion, which is released from the sarcoplasmic reticulum. Once the calcium binds with the troponin, it causes a shift in the shape of the tropomyosin, which opens up the myosin binding sites on top of the actin, which allows the actin and myosin to bind and form a cross bridge. The phosphate is released when the binding occurs, and when the myosin head flexes, ADP is released from the myosin head, thus causing actin to flex. When ATP interacts with the flexed myosin head, the myosin and actin go back to their normal position.
After death, the body will stop producing ATP. After a certain number of hours, the myosin heads will all be flexed. Since there is no ATP, the myosin does not relax, which puts the body in a state of flexion. This specific state is called rigor mortis. After some time, after rigor mortis has set in, the body will start to relax. Rigor mortis is very helpful in determining the time of death of a victim.
Thanks for watching.